Alright, hi guys, welcome to vertical asymptotes, holes, and domain. So we're going to address all three of those key attributes of a rational function graph and talk about these breaks in our domain. So we're going to identify these various breaks or discontinuities in the domain and note the differences between them. Some definitions. Vertical lines go up and down. Remember, side to side is horizontal. Vertical goes up and down. And they have the equation on them of x equals like a number. So they go up and down. Vertical lines are straight up and down. And this is their equation, x equals some number. Now, on our graph, we're going to have a dashed line. We call that one an asymptote. It's an invisible line on your graph. Well, since it's invisible, you can't see it, so we make it dashed to kind of represent that it's really not something you can see. But your function is going to get close to it, kind of like a fence, but it's never going to touch it. So kind of think of, you got cows out in the field and you don't want them to get out of your field, you put a fence up. Now that fence is your asymptote. Now your cows will get really, really close to it, but they can't go outside the fence. They never cross the fence. That's kind of an asymptote does. It's a boundary line, like a fence. Here's a little cute thing with Lilo and Stitch here. I'm not touching you kind of thing, with, Lilo is, poking towards Stitch there, and she's saying, I'm not touching him, but she's getting really, really close to Stitch, but she's not actually touching him. That's the idea of an asymptote. So here's a broken graph, or in our case, we call this a rational function. You notice it's got the fraction with an x in the bottom. That's how we know he's definitely a rational parent or a rational function. And he's in the two pieces. We just had some functions just like this where we had them in two pieces. And if we look at this guy, we're going to find the vertical asymptote. The vertical asymptote is the line that separates the two pieces left and right. It goes up and down. I'm not very good at drawing on here. There's my vertical asymptote. Remember, he's invisible. That's why we make him dashed. And it looks like he goes through 1, 2, 3. This is 3. So my vertical asymptote is x equals 3. And we abbreviate that as VA for vertical asymptote because it's up and down and it's invisible. So vertical asymptote. And all it does is separate your two pieces. Again, the vertical asymptote, that's the invisible line that separates your graph into your pieces. A hole is a point that's on your graph, but it's represented as an open circle. It's kind of like a pothole in the road. So you've got your graph going on, and then there's this little open circle, like a pothole in the road. Like here's your road, pothole, road. Open circle is like a point. Those are both discontinuities because they're a break in your graph. They break your graph into pieces. Okay, so we're going to first talk about domain. Remember, domain goes from left to right. It's the x values. So if you use some function. But first thing you're going to do is always factor top and bottom. Well, there's nothing to factor. X plus 2 and x minus 3, those are both, they can't factor any. Then the second thing you're going to do is after you factor is you're going to set the denominator equal to 0. The denominator, remember, is the bottom. So we're going to set this bottom equal to 0. And I'm going to solve. So to get x by himself, I got to move the 3 over. Now what do I do with that? This tells me that my domain, this is the answer, is all the real numbers except the number I just got, which is 3. 3 is where the vertical asymptote is going to occur. That's where it separates my graph into two pieces. So my graph is everything, all real numbers, for his domain, except not equal to 3. And I got 3 because I set the bottom equal to 0. We're going to try a bunch more of these so you'll get the hang of them. Okay, Now this one's going to be talking about not the domain this time, but it wants the vertical asymptotes. So again, I start out with my lovely function. And we should always factor top and bottom if we can. This one doesn't factor because I kept him pretty easy. And then we're going to cancel anything between the top and bottom. Again, it didn't factor, so nothing cancels. So now we're at the set the denominator that's not canceled equal to 0 and solve for x. So I go to my denominator. I have x minus 3. I set him equal to 0. Solve for x. That means I move the 3 over to the other side. And I get 3 again. Mostly because it's the same problem that we had a moment ago. But this time it's not asking for the domain. It wants the VA, the vertical asymptote. Remember, that's the up and down invisible line that separates it into two pieces. Well, that's actually the answer I just got. X equals, remember, there x equals a number, and the number I get is 3 from the denominator. So the domain where the break is, where it says not equal to, is the same thing as the VA's answer most of the time. There's a little bit of a little difference, but that's most of the time. Now here comes the difference. The word holes, remember those are the open circles like potholes. And notice I changed the problem quite a bit. I want to make it harder. So the first thing we're going to do is factor the numerator and denominator, or top and bottom. So I'm going to do some big X. In this case, A times C, 1 times 2 is 2. B goes on the bottom. And then I have to think of two numbers that when I multiply them together, I get 2. But when I add them, I get 3. So it'd be 2 and 1, because 2 times 1 is 2. 2 plus 1 is 3. Divide by A. A is 1. So on top here, I have x. 2 divided by 1 is 2, so I have x plus 2. And 1 divided by 1 is 1, x plus 1. I just factored. Now I'm going to do the big X for the bottom one. So A times C, 1 times negative 3 is negative 3. B goes on the bottom. And I use my brain again. Two numbers that multiply to give me negative 3, but add to give me negative 2 are negative 3 and 1, because they multiply to give you negative 3, but when you add them, they get negative 2. Divide by A. Now I'm going to write my answer. Negative 3 divided by 1 is x minus 3. 1 divided by 1 is 1. Now after I factor, I go to step 2. Cancel the common factors. So I look at them, I have an x plus 2, an x plus 1, and on the bottom I have an x minus 3 and an x plus 1. So what's common? What did I repeat? X plus 1. They're canceled. And that left me with x plus 2 over x minus 3. Now what do I do with that? It says we set the canceled factors equal to 0. I canceled x plus 1. So I'm going to take x plus 1, set it equal to 0, subtract 1 from both sides, and I get x equals negative 1. This is where my pothole, my hole is located. I said find the holes. The hole is at x equals negative 1. Look at that. So now we've looked at the fraction. We factored, canceled, we figured out holes, that's the things that are canceled. We found the domain, and we even found VAs. Now we're going to put all this stuff together, because that's a lot to go over. So the first thing I'm going to do is I'm going to go through each of these problems and see if anything needs to factor. Not on the first one. Ooh, the second one here. The bottom, x squared minus 4, he factors. So A times C, 1 times negative 4. There's no B. I gotta figure out who multiplies to give me negative 4 but adds to give me 0. That's 2 and negative 2. Divide by A. So this problem is x plus 4 over 2 divided by 1 is x plus 2. Negative 2 divided by 1 is x minus 2. Okay, I'm just going to go through each one of these and factor. Now, I look over here at number 3. The top doesn't factor. Oh, the bottom. And we just did that. We just factored the bottom on the other one, and they're the same exact problems on the bottom. So I'm just going to copy what I just found. Actually, I have no idea why I just wrote that. This says x minus 2 on top, but the bottom's matched. So down here is x plus 2, x minus 2. Okay, this one down here in the left corner, that doesn't factor. Oh, this one does. The top does. 2a times c is negative 30. And b goes on the bottom. Now I have to think of two numbers that when I multiply them, I get negative 30. But when I add them, I get negative 7. That's negative 10 times 3. Makes negative 30, but when I add them, I get negative 7. Divide by a. Okay, I'm going to rewrite this problem. So negative 10 divided by 2 is negative 5. And 3 over 2, remember that's like x plus 3 over 2. And then we slide and divide, so that becomes 2x plus 3. And on the bottom, that doesn't factor. So I just went through every problem and did the factor step. Now I'm going to see if there's anything on top and bottom that can cancel. So I'm going to take my marker and go through. X plus 2 and x plus 4, those don't match. Over here, x plus 4, 2, and negative, none of that matches. Oh, here, the x minus 2's go and cancel. Whenever you have something divided by itself and it goes away, this turns into the number 1 up there, because something divided by itself is 1. So if everything cancels out, you still get a 1. This one, these don't match. Oh, here, the 2x plus 3's match. Okay. Now, after both of those that I canceled, this became 1 over x plus 2 left. And this one becomes just x minus 5 because the other stuff's canceled. All right. Now I'm going to start getting to work. So my domain was setting whatever was in the original problem in the bottom equal to 0. So domain, I'm going to abbreviate that capital D for domain, is setting the bottom equal to 0 and solving for x. So I get negative 4. So the domain is all real numbers except negative 4 on the first one. Now I'm going to move to the second one. I had to kind of factor them all out. Nothing cancels. But even before I would cancel, I set the bottom equal to 0. So the domain, I would set x plus 2 and x minus 2 equal to 0. Solve for x. That becomes negative 2. And that becomes positive 2. So my domain would be all real numbers except negative 2 and positive 2. Now this guy over here, I would still set the original bottom equal to 0 on the domain. So x squared minus 4 equals 0. Add 4 to both sides. X squared equals 4. To undo a square, remember we square root. So x equals plus and minus 2. So his domain is all real numbers except plus or minus 2. And we go over here, set the denominator equal to 0. So domain is 2x plus 3 equals 0. Solve for x. I'm going to subtract 3. Divide by 2 on both sides. So I get negative 3 over 2. So his domain is all real numbers except negative 3 halves. here I'm going to set the bottom equal to 0 for his domain. 2x plus 3 equals 0. And I'm going to cheat because we just did 2x plus 3 equals 0. And so that means that it's all real numbers except -3/2. Okay, so now I found everybody's domain, all 5 problems. I'm going to change my pen's color to blue, and I'm going to do the VAs. Remember, those are the up and down dashed lines. So VAs are basically the same answer you got in your domain when you didn't cancel for your holes. So I didn't have any canceling on the first one, so my VA is x equals -4. It's the same answer you got for your R not equal to. Now this one, I didn't have any canceling either, so my VA, there's actually 2 of them, is at -2 and 2. Over here, I had the x -2's cancel, so I was left with an x plus 2. When you set the x plus 2 equal to 0, that gives you x equals -2. So that's the VA. So this one, I only get one of the answers for the VA because the ones that I canceled, those are going to be the holes in a minute. This guy, nobody's canceled. So the VA is the same thing as I got for the domain, except I put x equals that answer instead of R not equal to the answer. Here, everything canceled out of the bottom, so there's no bottom down there. So there is no VA, as in the word none. There isn't one because it's all been canceled. There's no more denominator. Now I'm going to do my holes, my open circles in the graph. Now holes are anything I've canceled. On this one, the first one, there's no canceling, so my holes are the word none. I didn't do any canceling. This one, there was no canceling, so my holes on number 2 is none. I didn't cancel anything. On number 3, I canceled x minus 2's. So on number 3, I'll fit him right here, the holes, I take x minus 2 and set him equal to 0, the thing that I canceled, and I get 2. So my hole is at 2. It makes sense. My R is not equal to, all real numbers is not equal to, plus and minus 2. The VA is -2, so that means +2 has to be the hole. Now I'm down here to number 4. Nothing that canceled on him, so my holes are none. And then the last one, I canceled a 2x plus 3 on top and bottom. So my holes, that's my 2x plus 3 equal to 0. And we've actually solved 2x plus 3 equal to 0 already. That gave us -3/2. So my holes are at x equals -3/2. And if remember, our domain was all real numbers except -3/2. And we didn't have a VA, so that guy must be the hole. So now you're going to be doing some of these on your paper. You're going to be taking the functions. You're going to find their domain. You're going to factor it top and bottom completely. Anything you canceled that looked the same on top and bottom will give you your holes. Anything that didn't cancel from the bottom is your VAs.